Good morning, students. Welcome back to science class on the chapter science. So, on the chapter motion. Yesterday, the day before yesterday, just we started motion chapter, and also we had studied about motion and rest. Okay, you know what is motion? Motion is nothing but if an object changes its positions continuously with respect to time. Okay, so then we can call that is a motion. Then what is a rest? Rest means if an object doesn't change its positions continuously with respect to time. Okay, so then we can say that that object is at rest. Okay, see, normally both motion and rest are opposite to each other, but in a science we call both rest and motion are relative terms. Okay, see here. Before that, suppose this is position A and you are standing here. Okay? See, one person is standing here. Okay, when do you say that this person is moving? Okay, when this person leaves this position, okay, leaves this place, then only you can say that that person is leaving, that person is moving. Okay, just imagine now I am here. Okay, if I leave this room, then you can say, sir, you are in motion. If the just imagine if the room is moves along with you, then you can't say what I am in motion. Here also, if this position is moves along with him, okay, you can't say he is in motion. Okay, if you want to say one object, if it is in motion, then it should leave some places, right? For example, this is A, this is B, and this is C. Okay, if the person leaves this place and place B and place C, then only you can say that that person is moving. Okay, see, with respect to these points, because these points are here and these places here only, the person is moving. With respect to these places, you will say that that person is in motion. Okay, so now this point we call this is the origin. Okay, this reference point is called origin. Okay, with respect to this place, the person is moving. Okay, if the person moves along with you, then you can't say that that person is in motion. Okay. Just this is a bus, and here two persons are sitting, person A and person B, and one person standing outside. Okay, the bus is moving. Bus is moving. Okay, so now here the bus is moving means what? Both the passenger are also moving. Now see here, with respect to person A, person B is at rest. At rest. Here you can't say person B is in motion with respect to A. Why? Because here bus is moving, which means the person B is also moving. See, along with person B, even the person A is also moving, right? So both are moving. Okay, see, if the person is sitting here only, just imagine the bus is standing, okay, then the person B, if the leaves this place, then you can say the person B is moving with respect to person A. So, but here the bus is moving, both the passengers are inside the bus, okay, and both A and B are moving. So clearly we can say that with respect to person A, the person B is in motion. Sorry, the person B is at rest. Okay, why? Because the person A is also moving along with B. But what about the with respect to person C? Okay, for him, the bus is moving, which means the passengers are inside the bus. So here the person B, with respect to person C, the person B is in motion. Okay, for A, person B is at rest. With respect to person C, person B is in motion. Okay, so due to here we can call both motion and rest are relative terms. For him, for person A, person B is at rest. For person C, the person B is in motion. Okay, just imagine now I am here, I am standing here, so you can call I am at rest. So with respect to this room, I am at rest. But just imagine you are able to see my face, you are standing outside the earth. It is difficult. Just imagine Okay, so now you know earth is moving, right? I'm inside the earth, the classroom also inside the earth, which means the classroom is moving. Okay, so with respect to the man who is standing outside the earth, I am in motion, but with respect to this classroom, I am at rest. Okay, so due to these reasons, we call both motion and rest are relative terms, not opposite terms. Okay, clear, right? So that's why, see, now can you give an example, sir? This object, it is exist at rest. No, you can't, right? Because in this universe, all the objects are in motion. Here we can say this object is at rest with respect to something. Okay, so now just imagine this board. So with respect to this classroom, this board is at rest. Okay, so now I am also simply standing here. So with respect to me, this board is also at rest. But if you look, if you see this board outside from outside the earth, okay, then for you it is in motion, correct? So that's why, so we call both motion and rest are relative terms. Okay, so when do you say that an object is in motion? If an object changes its positions continuously, it should change its position continuously. For example, this is A, this is B, and this is C. One person is here. Okay, see, he will cover that this distance A to B, say 3 meter distance in 1 second. In 1 second, then he will take 1 second rest at B, at position B. Then once again he will cover the 5 meter in 2 seconds. First he will travel 1 second, then he will take 1 second rest. Okay, then he will start his journey. So here we can't say that person is in motion. Why? Because that object, okay, sorry, that person he is taking what rest at position B, right? Okay, if you want to say one object it is in motion, then it should change its positions continuously, whether it is slow or speed, whatever. Okay, but that object should changes its position continuously. Then we can say that that object is in motion. Okay. Next, rest means if an object doesn't change its positions continuously with respect to time, then we can say that that object is at rest. Okay. So next, to move to distance. Distance. Okay. You know. We have used many times, right? Still you are using, you will use this term, the distance. Okay, if I will ask, so what is the distance between Yadgir to Bangalore? You will say that it is a 600-kilometer distance. You will say like that. Then what is the mean? Then what is the distance? See, the distance means it is an actual path covered by a moving object. It is an actual path covered by a moving object. For example, now this is A and this is B. Okay, one person he will travel, or say one object. Okay, object he will cover 10-meter distance. 10-meter distance. Okay, that object it will travel A to B using this path. Okay, so now this path is the actual path of the this object, right? Okay, then we can call this is the distance. So distance means it is an actual path covered by a moving object. Okay, or for example, say another object. Okay, it will travel using this path. Say it will travel 25 meter. Okay, that object will travel using this path. Now this is the actual path of that object. Okay, so now distance covered by that object is 25 meter. Okay, clear? See, now I am here. Okay, so now I will cover 1 meter distance. 1 meter distance. So now this is, see, this is my actual path, right? So now this 1 meter is the distance covered by me. Clear? So distance means it is an actual path covered by a moving object. See, we measure a distance in millimeter, centimeter, meter, kilometer. Okay, but the SI unit of distance is meter. Okay, we can express the distance in millimeter, centimeter, kilometer, meter, whatever. But the SI according to international, the SI unit of distance is meter. Okay. So distance means it is an actual path covered by a moving object. Or see, now this is A, B, and distance is 25 meter. Okay. See, now this is the actual distance 25 meter. See, you can travel like this, or you can travel like this. Okay. See here, if you travel using this path, say this is a 30 meter, and say this is a say this is a 35 meter, and this is 30 meter. Okay. See, this is the 25 meter is also the distance. Okay. See, now that person will travel using this path. At that time, you can't say, sir, here 25 meters is the distance between A and B. It's wrong. Okay. But that object or that person used this path, right? So then this is the actual distance of that object. Okay. So if that object is traveled using this path, then we can say 35 meters is the distance traveled by that object. If that object is traveled using this path, okay, so then this is the actual path. Then we can call 25 meter. 25 meters is the distance. Suppose if the object uses this path, then this is its actual path. Then we can say distance covered by that object is 30 meter. Okay. So distance means it is an actual path covered by a moving object. So next move to displacement. Displacement. Okay. See, displacement means it is also distance. Okay. The actual meaning of displacement is the shortest distance between 2 points. Okay. The shortest distance between 2 points. For example, say this is A and this is B. Okay. So now this is the shortest distance, right? Okay. So now here we can say that displacement is 10 meter. See, you can travel from A to B using this path. So this is 20 meter. 20 meter. Okay. So one object it will travel using this path. So then I will ask, what is the displacement of that object? Okay. So here you can't say the displacement is 20 meter. See, that object used this path. Okay. To travel, that just imagine that object used this path. Okay. So here we don't want actual path. See, this is the distance of that object, because this is the actual path, right? For displacement, we don't want actual path. Just we need where that object started its journey and where it ended. Okay? Or we need just the shortest distance between starting point and ending point. Starting point A and ending point B. Then what is the shortest distance between A and B? That is 10 meter. Okay. So here displacement is 10 meter. Clear? So displacement means it is the shortest distance between or starting point and ending point. See, now see one. Just imagine one object. Okay, so that object is x. Okay, object x, it will travel using this path. Then distance covered by that object is 30 meter. 30 meter. Okay, then I'll ask what is the displacement. So if you want to calculate displacement, just you need starting point and ending point. Okay, starting point A and ending point B. So clearly we can say that displacement is 25 meter. See, remember there, see that object traveled using this path. Okay, not this path. Clear? That object traveled using this path. So here we can say that this see, this is the actual path, right? So that's why distance covered by that object is 30 meter and displacement is 25 meter. Okay. So we measure see, displacement is nothing but the distance, right? But it is a shortest distance. So we measure displacement in millimeter, centimeter, meter, millimeter, centimeter, meter, and kilometer. But the SI unit of displacement is also meter. Okay. Now see here. Consider one object. First, it will travel A to B, A to B. Okay. Then B to C. Okay. Then I'll ask, what is the distance and displacement? What are the distance and displacement? Okay. So first, distance is, see, here to 10 and here to 10. That is 20 meters because this is the actual path. Then what is the displacement? Displacement is equal to, see, displacement is the shortest distance between 2 points. See, started at A, ended at C. So what is the shortest distance? So this straight line is the shortest distance, right? You know, this is okay. See, now I want to travel from this end to this end. Which is the shortest path? You know, see, straight line. This straight line is the shortest path, right? Shortest path. Okay. So the distance nothing but it is the shortest path on a straight line, starting point to ending point. Okay. So now here the distance, see, started at A, ended at C. So what is the shortest distance between A and C? So 10 plus 10. So that is 20 meter. That is 20 meter. So distance is 20 meter and displacement is also equal to 20 meter. So now just observe here. So here we can say distance is equals to displacement. Okay. So now this is straight line, right? So here distance equal to displacement. Next. Okay. Consider one more object. See, it will start its journey at A, first reaches B, then it reaches C, then it will come back to point B. First A to B, then B to C, then C to B. Okay. So now here, what is the distance? What is the distance? See, distance means it is an actual path covered by a moving object. So first A to B, B to C, then C to B. So this is the actual path of that object. Okay. First A to B 10 meter, then B to C 10 meter, then C to B 10 meter. Total 30 meter. So distance covered by that object, it is 30 meter. Then what is the displacement? What is displacement? See, displacement means what? It is the shortest distance between 2 points. Okay. See, starting point is A and ending point is B here, not C, because first that object traveled A to B, B to C, then C to B. That object ended its journey at B. So now starting point A and ending point B. Then what is the shortest distance between A and B? I told here we don't want actual path, just we need the shortest distance between starting point and ending point. Okay. So now starting point A, ending point B. So now the shortest distance between A and B is 10 meters. So here in this case displacement is 10 meter. Okay. Displacement is 10 meter. See, now consider one more example. One more object. First it will travel A to B, then B to C. Okay, then C to B, then B to A. Okay, then what is the distance? What is the distance? First A to B, B to C, then C to B, then B to A. See, first A to B 10 meter, then B to C 10 meter. That is 10 plus 10, total 20. Then C to B plus 10, that is 30. Then B to A plus 10, total distance covered by that object is 40 meter. Then what is the displacement? Then what is displacement? See, starting point A and ending point A only. Then what is the shortest between the starting point and ending point? See here, both the starting ending points are same, right? If the both the points are same, then there is no distance. There is no shortest distance. Okay. So in this case, displacement is 0 meter. Okay. In this case, displacement is 0. See, keep in your mind, when the starting and ending points are same, when the starting and ending points are same, then the displacement is equal to 0. Clear? Now take the distance from here to B is 10 meter, and here 50 meter, and here 20 meter. Okay. So now one object, it will start its journey from A, it travel A to B, then B to C. Then what is the distance traveled by that object? Say distance means actual path. So now first A to B, then B to C is the actual path of that object. Okay. So then tell what is the distance. So A to B 10 meter, then B to C 50 meters. So 10 plus 15, it is 25. 25 meter. Next, what is the displacement? What is the displacement? So displacement means the shortest distance between starting point and ending point. Okay, started at A, ended at C. So now this is the shortest distance, right? So here displacement is 20 meter. Okay, displacement is 20 meter. You know, for a moving object, distance never equal to 0. Okay, for a moving object, distance never equal to 0. Are you getting my point? For a moving object, distance is never equal to 0. But for a moving object, sometimes displacement may equal to 0. Okay, for a moving object, distance is not equal to 0. But for a moving object, sometimes displacement may equal to 0. You know, when both the starting and ending points are same, then displacement is equal to 0. Okay. Next, for a moving object, sometimes both distance may equal to displacement. Okay. For a moving object, sometimes distance may equal to displacement. Already we have seen one example, right? Okay. Next, for a moving object, sometimes distance may greater than displacement. For a moving object, sometimes distance may greater than displacement. Okay. Next, for a moving object, displacement is not be equal to distance. Sorry, cannot be greater than distance. For a moving object, displacement cannot be greater than distance. Always displacement, it should be equal to distance, or it should be less than distance, or the distance may equal to 0. But for a moving object, displacement cannot be greater than distance. Okay, so I'll repeat once again. For a moving object, displacement may equal to distance, or displacement may equal to 0, or sometimes displacement may less than distance, but displacement is never greater than distance. Okay, for a moving object, displacement never greater than distance. Okay. So, so this is point A. Person A and person Y. See, this is point A. Okay, and so this is point B. The distance from A to B is 100 kilometer. 100 kilometer. Okay, 100 kilometer. 100 kilometer. Okay, so now person A, he will cover this 100 kilometer in 3 hours. In 3 hours. Next, person Y covers the same distance, 100 kilometer distance, in 2 hours. I'll ask, who is first, person A or person X or person Y? So clearly we can say that person Y is faster than person X. Why? Because the person X covered 100 kilometer in 3 hours, but person Y covers the same 100 kilometer in 2 hours. Okay. But the person Y, he took less time. Okay. Person A took 3 hours and person B taken 2 hours. Clear? So clearly we can say that person Y has person Y is more faster than person X. So now to decide whether the object is how fast or slow, for that we use one more physical quantity, that is speed. Okay, to describe how the object speed or how fast or slow, to describe that one we use, that is speed. Okay, so speed means the distance covered by an object, the distance covered by an object in a given time. Okay, so to calculate that speed, we have a formula, that is distance is, speed equal to distance by time. Okay, so speed means, so it is a distance traveled in a given time. Okay, so now how do you measure speed? What is the SI unit we use for speed? See here, we use, speed equal to distance by time. We measure distance in meter and time in second. Okay, the SI unit of speed is meter per second. Okay, the SI unit of speed is meter per second. Okay, so speed means it is the distance covered by an object in a given time. Okay, so in a given time, how much distance covered? Okay, so we call it as speed. Now here this is point A and point B, and remember here we are studying motion in a straight line. Okay, we are studying motion in a straight line. Now see here, the distance from A to B is 10 meter, and one object, it will cover this 10 meter in 2 seconds. I will ask, what is the speed of that object? Okay, so now to calculate speed, we have a formula, that is the speed equal to distance by time taken. So what is the distance? A to B distance is 10 meter and time 2. Then what is the answer? 2 answer, 2 5. So speed is 5 meter per second. Okay, speed is 5 meter per second. The distance between point A and point B is 20 meter. See, say person X, he will cover that this 20 meter in 4 seconds, and one more person Y, he will cover that same distance in 5 seconds. I will ask, who has more speed, whether X or Y? Okay, first calculate the speed of X. Okay, so speed equal to distance by time. Distance by time. Then what is the distance? Distance is 20 meter. Then time is 4 seconds. So what is the answer? That is 4 answer 4 5 are 8. So 5 meter per second. So now I will calculate speed of y. Speed equal to distance by time. So what is the distance? 20 meter only. But what is the time taken? 5 seconds. So 4 meter per second. See here, speed of a person x is 5 meter per second. So which means object in that person x, he covered 5 meter in 1 second. Okay. Next, here the speed of y is 4 meter per second. Here person y, he covered 4 meter distance in 1 second. So clearly we can say that person x has more speed than person y, or we can say that person x is more faster than person y. Okay, we cover 25 meter in 5 seconds. Same this is also person x, and one more. And say person y, he will cover this 30 meter distance in 10 seconds. In 10 seconds. Okay. So now calculate the speed of x and y. So speed of first I get speed of y. Speed equal to distance by time. So distance is 30 meter and time is 10 seconds. So this is answer is 3 meter per second. So 3 meter per second is the speed of y. And here speed equal to speed equal to distance by time. So what is the distance? That is 25 meters. Then what is the time taken? 5. The answer is 5 meter per second. So here person y, he covered 3 meter in 1 second. Okay, and here this person x, he covered 5 meter in 1 second. Okay, so clearly we can say that person x has more speed than person y. Okay, his speed is 5 meter per second and his speed is 3 meter. So here person y, he will cover 3 meter for every 1 second, and here next he will cover 5 meter distance for every 1 second. Okay, so I will stop here. Tomorrow I will continue the class.